Question 5. The circle C has centre 3, 1 and passes through the point P, 8, 3. Find an equation for C. Well, let's write down the general equation for a circle first of all. If we've got a circle with centre AB and radius R, then its equation is given by x minus a all squared plus y minus b all squared equals r squared. Well, we've already got the centre 3, 1, but we don't know the radius at the moment. But P is a point on the circumference, so the radius is simply the distance between these 2 points. So let's find the radius. The radius r will be given by the square root of the difference in the x coordinate squared plus the difference in the y coordinate squared. So it's simply going to be 8 minus 3 squared plus 3 minus 1 squared. So r is equal to the square root of 8 minus 3 is 5, square root is 25, plus 3 minus 1 is 2, square root is 4. So r is equal to root 29, which means the equation of this circle is x minus the x coordinate of the center point squared plus y minus the y coordinate of the center point squared is equal to r squared, and root 29 squared is 29. So that's the equation of the circle. Second part of the question, find an equation for the tangent to C at P, given your answer in the form ax plus by plus c equals 0, where a, b and c are integers. Well, let's have a diagram to start with. And I want a tangent to this circle. And let's have a line from the center to the point where the tangent touches the circle. And the angle between a tangent and a radius will be 90 degrees. So what I've got here, let's call the center O. And O is the point 3, 1. And P is the point 8, 3. Now to find the equation of this tangent, I need a point on the line, 8, 3 will do nicely, but I also need to know its gradient. Well, I haven't got the gradient of the tangent, but I can work out the gradient of the radius. And then there's a relationship between the gradient of 2 perpendicular lines we can use to find the gradient of the tangent. So let's begin by find gradient of OP. And that's simply given by the difference in the y coordinates divided by the difference in the x coordinates. Let's say y2 minus y1 over x2 minus x1. So that could be 3 minus 1, 3 minus 1 divided by 8 minus 3. And that comes to 2/5. Now then, we can say, therefore, the gradient of the tangent is equal to minus 5 over 2, because the gradient of 2 perpendicular lines multiply together to give minus 1. So 1 is the negative reciprocal of the other. And now we can use y minus y1 equals m times x minus x1, which is an equation for giving you the equation of a straight line when you've got a point x1, y1 on the line and it has gradient m. So substituting in our values, we get y minus the y coordinate, 3, is equal to minus 5 over 2, the gradient, multiplied by x minus 8. Now let's multiply through by 2, and we get 2y minus 6 is equal to minus 5 x minus 8. Take the brackets off. 2y minus 6 is equal to minus 5x, and minus 5 times minus 8 is plus 40. Now let's get it in the form they wanted, with everything on one side. Bring everything to the left. The minus 5x becomes plus 5x. I've already got a plus 2y. I've got minus 6, and when the plus 40 comes across, it becomes minus 40. Minus 6 minus 40 is minus 46. And we've now got the equation of the line in the form they want. 5x plus 2y minus 46 equals 0.